AI workflows aren't single requests. They're multi-stepped interactions where every step depends on the backend that started it. As long as nothing changes, that works fine. But what happens when something does change? The first task in this example is investigation. The AI assistant calls observability tools through a MCP extension to find the cause. Both requests land on the same MCP server. That's not coincidence. NetScaler uses the MCP session identifier to pin every request in a session to the backend that owns its state. Without that pinning, multi-stepped MCP workflows would break. Once the inspection finishes, something changes on the backend. One of the backend MCP servers is still accepting TCP connections, still responding to HTTP health checks, but it is no longer serving MCP. A standard load balancer asks two questions. Is the backend on the network? Is the web server responding? Both answers are yes. NetScaler asks a third question. Can the backend actually serve MCP? It runs the protocol's own initialization handshake. If that fails, the backend is marked down. Same backend, same network, only the MCP-aware probe catches the failure. Let's now continue our workflow with the next task. The assistant pulls fresh logs as part of the fix workflow. Watch the routing decision. Because one of the MCP servers is marked down, NetScaler routes the new session to a new MCP server automatically. The failed backend stays out of rotation. New sessions go to healthy instances. From the developer's perspective, no errors, no retries, no incident. All because NetScaler caught what other monitors miss and routed around it before anyone noticed. Stateful AI, protocol-aware health, recovery you don't have to think about.